Hey guys, it's 3:46 p.m. I have tutoring officially at 4 o'clock, as you guys saw in the group me message. So let's see how fast we can do this and see if I can still make tutoring at 4 o'clock on time. All right, so this is all our online quiz 2 limits 2, and let's get right into it. This one says limit as x approaches 0 from the right, and I have x over absolute value of x. Hopefully by now, guys, we have an idea how this function looks like. So since I have the same magnitude all the time, you're always going to get 1, but it just depends. If you're talking about positive numbers, I'm going to get positive 1. So think about it. 5 divided by 5, 10 divided by 10, 100 divided by 100, it's always going to be 1. Now, if I'm talking about x values that are negative, well, the numerator is going to be negative, but the denominator is always going to be positive. The magnitude is always 1 again. So positive divided by a negative, or I guess negative divided by a positive if you want to be a technical there, and that's going to be negative 1. You are undefined at 0, but this function, this is not saying what is f of 0. This is saying what's the limit as x approaches 0 from the right. So I'm approaching 0 from the right. So that y value is 1, so 1. All right, guys, on this one, I'm doing direct substitution. The square root of x minus 8 has domain all real numbers, or all numbers larger than or equal to 8. So that's the only way I can go. I can only go from the one direction, from the right-hand side. So I can just do direct substitution on this one. Square root of 8 minus 8, that's an 8. It just came out squiggly there. Divided by 8, 0 divided by 8, that's 0. So it actually starts at 8, the domain. It's from x is greater than or equal to 8, and it starts at 8, 0, and then goes on forever to the right. So what's my limit? 0. Sorry if I'm being extra there. I'm just letting you guys know I'm on that right there. All right, this is actually 1. This is not tested on AP, but it's a good question, guys, and it's the same one from the notes. I guess I could have switched it up if I wanted to, but let's just leave it, guys. And all this means really, this is epsilon. This is delta, lowercase delta, and lowercase epsilon. And like I said, epsilon is like error. So I want my error to be no larger than 0.01. And really all this means is how close must x be to 2 so that x over 3 is within 0.01 of 2/3. That's all it means. So I'll write it here. How close must x be to 2 so that x over 3 is within 0.01 of 2/3. All right, so let's do that, guys. So since I want to be within 0.01 of 2/3, I want to take the difference, right? So the absolute value of x over 3 minus 2/3, and I want this difference to be no larger than 0.01. So there it is. And now I'm just going to solve for x, guys. Absolute value of x minus 2 over 3. I want that to be no larger than, again, 0.01 times 3 times 3. And this is actually where we're going to stop here. Oops, that's an x minus 2, not x minus 3. X minus 2 less than or equal to 0.03. If I wanted the x values, they don't. They say find the largest delta there. If I wanted the x values, I would say x values have to be between, let's see, 0.03 plus 2, that's 2.03. And 0.03, 2 minus 0.03, that's 1.97. So here are my x values, but you can stop right here on this one. So there is your delta there, 0.03, and so you look for 0.03, and it's this one. 3 divided by 100 is 0.03. I hope we understood that one, guys. Oh, that happy face didn't come out very good. There we go. I hope we understood that. If we didn't, let me know, and we can go back and chat about it, guys. Or rewind it and play it again one more time. So this one here, we're just using properties. Evaluate the limit of x approaches c of h of x. I look for h of x. This is the only one that has h of x. It has a 2 on it. So I can just do 2 to the 3rd power, and that's 8. This one you can just do direct substitution. I have an absolute value, so I can just go absolute value. 2 times negative 2 minus 10, close absolute value. So let's see, absolute value of negative 4 minus 10, close it. So that's absolute value of negative 14, and the absolute value of negative 14 is 14. Delete B, that's the worst one, guys. Absolute value means it's always going to be positive. On this one here, guys, I would distribute the h. So here's what I have. Limit as h approaches 0. Notice I'm writing the word limit because I haven't evaluated anything. 6h plus 3 over h. Notice that it's no longer squared because one of the h's in the top canceled with one of the h's in the bottom, and since I had two of them, hence the h squared. So now it's just 1h. I can't do direct substitution because if that 3 over h were its own function, I would have a vertical asymptote at 0. So this one does not exist. Yay, we're happy campers, guys. All right, this is square root. And notice, here's a big hint, guys. X squared of x, 121, 11. So hopefully you recognize that the top is just the difference of squares. Square root of x times square root of x is x. 11 times 11 is 121. Yes, I realize you can solve this also by multiplying by the conjugate of the denominator, and that will work as well. But I think this is easier, guys. I'm going to write the word limit. I'm going to write as x approaches 121, and I'm just going to do the difference of squares in the top. Square root of x minus 11, square root of x plus 11. All this is divided by square root of x minus 11. And now that I have those factors in the top, I can see that one of the factors is going to cancel out, those two. And now I can do direct substitution. Square root of 121 plus 11. Well, the square root of 121 is 11. 11 plus 11 is 22. All right, we're doing good timing, guys. Let's keep going. So on this one, I need to find a common denominator on everything. And they're making things kind of nice for me because they put a 1 there. So I'm going to write the word limit as h approaches 0. And I'm going to write h squared over h squared minus 16 over h squared over h squared over h squared plus 16 over h squared. So what I really have now, limit as h approaches 0, h squared minus 16 over h squared over h squared plus 16 over h squared. If you want, you can do keep, change, flip. So I'm going to keep this fraction. I'm going to change that division to a multiply, and I'm going to flip or just take the reciprocal of the denominator here. So limit as h approaches 0, h squared minus 16 over h squared times h squared over h squared plus 16. And you can see the h squareds are going to cancel out like so. And now I just have, and I'm still writing the word limit because I haven't evaluated anything, limit of h squared minus 16 over h squared plus 16. And maybe I'm being extra. Maybe you could have seen right here that the h squareds canceled out anyways, and you would have had h squared minus 16 over h squared plus 16. So, to each their own, whatever you think is necessary. Now I can do direct substitution, guys. And if I do direct substitution, I get a negative 16 over a positive 16, because 0 minus 16 is negative 16. And then 0 plus 16 is a positive 16. And then that reduces to negative 1. Yay. All right. And then this one's actually from our example or in our notes, but not everyone has our notes. So let's just go ahead and take care of it, guys. F of 9 is 9 squared minus 9 times 9. So 9 squared is 81. 81 minus 81 is 0. So now I can just write limit as x approaches, 9. F of 9 is 0, by the way. So I'm just going to write f of x squared minus 9x over x minus 9. There we go. I can't do direct substitution because I'll get 0 over 0, which means I definitely have a limit, right? Because it's indeterminate form. So I'm going to write the word limit as x approaches 9. I'm going to factor out an x. So I get x minus 9 over x minus 9. Those x minus 9s cancel out. And now I can just have the variable x. As x approaches 9, I'm approaching 9. If you're wondering how that graph looks like, it looks something like this, where that y value is obviously at 9, 9. And there it is. Ooh, is this the last one? No, we still got another. Don't worry, guys. They're not that bad. Limit as x approaches c of f of x exists. Okay. So they're telling you that it exists. Limit as x approaches c of square root of f of x exists. Okay, if then, they want to know if it's true or false. All right, with this, you're just going to have to put a little bit of thought into it, guys. Since I have a square root, this has to be false. Chavez, I don't understand. You already had the answer in there. Can you please give me a reason? Yes, I can. Well, what if f of x was a negative number? If f of x would have been like 9, or something like that. Oh, sorry, that's not even a negative number. Negative 9. I can't take the square root of a negative 9. And yes, it's imaginary, but we're not talking about that form, guys. We're just talking about, does it exist in the real world, in the real domain? So it doesn't. It does not exist. So there it is. So it's false. So you can't have negative numbers. The f of x cannot be negative if you want the limit of x approaches c of the square root of f of x to exist. So hopefully that made sense to you guys. All right, so these are my rules for horizontal asymptote. This is like end behavior, guys. So end behavior, spin an ocean. That 3x is the ocean. That 5x squared is the ocean. The denominator is larger. The denominator has a higher degree. So that means the denominator is growing faster than the numerator. So it's 0. And there it is. Let's go to the next one. And this one, the numerator has a higher degree than the denominator. So that means this question, this limit, is not converging on anything specific. It just keeps getting larger and larger and larger. So that means this one is infinity or does not exist. Yay, guys, we made it just almost perfectly on time. All right, guys, I'm going to go ahead and start the tutoring session right now. So I'll open up the Zoom. Hope you guys are happy. See you guys in a bit.